So, speed problems. Um, these take a little bit more thinking, I think, but they're not too bad. So let's look at number one. Um, a boat traveled 189 miles downstream and the same distance back. The trip downstream took 9 hours. The trip back took 27 hours. Find the speed of the boat in still water and the speed of the current. So, first of all, a useful equation to know for this is that speed times time equals distance. This is not just for this problem, this is like universal. So for all the speed problems, you'll pretty much be using this equation. So for the first trip downstream, they're telling you that some speed they were going times 9 hours took 100, they traveled 189 miles. And then for the second trip, some other speed times 27 hours led them a distance of also 189 miles. So for the speeds, the first speed is going to include the speed of the boat. I'm going to say B plus C for boat and current. The second speed, the boat was going against the current. So it'll be the speed of the boat minus the speed of the current. So that's how you'll set up these two equations. So first you'll have the speed of the boat B plus C times 9 equals 189 miles. And then B minus C times 27 equals also 189 miles. So I'm going to first isolate one equation so I can do a solution by substitution. So here I'm going to divide both sides by 9, so that'll give me B plus C equals 21, I think. Let's check. By 9. Yeah. So if I divide both sides by 9, I get B plus C equals 21, and then I'll get B equals 21 minus C. So I isolated for B. You could isolate for whichever variable you want. And then I'm going to take this and I'm going to substitute it in for B over here. And to do that, I'll rewrite it this way. 21 minus C times 27 equals 189. So 21 minus 2C times 27 equals 189. And then I'm going to distribute this 27 here to the 21 and the 2C. So 21 times 27 is 567. And then 27 times 2 is 54. So now I'm going to solve for C. I'm going to subtract 567 from both sides. So negative 54C equals 189 minus 567, which is negative 378. And then if you divide 378 by 54, you get 7. So the speed of the current is 7 miles per hour. And now to find the speed of the boat on its own, you can take this c equals 7 and put it in up here. So that's going to be b equals 21 minus 7. So b equals 14 miles per hour. So that's how you do a speed problem. I'm also going to do number 2. So a plane traveled 1,120 miles to Chicago and the same distance back. The trip there was with the wind and took 10 hours. The trip back was into the wind and took 20 hours. So find the speed of the plane in the still air and speed of the wind. So I'm going to do the exact same thing I did before. I'm going to say that the speed of the plane, which is p, plus the speed of the wind, which is w, equals speed 1, which is the speed that it took for the first trip, and then the speed of the plane minus the speed of the wind, since they're traveling against the wind this time, is going to be s2. So you can say speed 1 times 10 hours equals 1,120, and then speed 2 times 20 equals 1,120. So speed 1 equals p plus w, so I'm going to rewrite that. P plus w times 10 equals 1,120, and then p minus w times 10 equals, or sorry, not times 10, times 20, times 20 equals 1,120. And then I'm going to isolate the p variable from the first equation so I can do solve the system by substitution. So I'm going to say divide both sides by 10 and you get p plus w equals 112, which means p equals 112 minus w. And now I can solve by substitution. So I'm going to take this 112 minus w and put it into here. So 112 minus w times 20 equals 1,120. And then 112 minus 2w times 20 equals 1,120. And now I'm going to distribute this 20. So 20 times 112 is equal to 2,240 minus 20 times 2, which is 40, equals 1,120. And then I'm going to subtract both sides by 2,240. So negative 40w equals 120 minus 2,240, which gives you negative 1,120. So if I solve for w up here, w equals negative 1,120 over negative 40. So w equals 28. So the wind is going at 28 miles per hour. And now to find the speed of the plane, I'm going to take this answer and I'm going to put it into here where it'll be easy to solve. So p equals 112 minus 28. That gives you heat equals 84 miles per hour.